Easter. It is Monday night, April 13th. We start back to school tomorrow for real. Let me give you some information on what's going on that I know of from administration. The 9 weeks, for the third 9 weeks, is going to end this Friday. I don't know what date, the 17th, I think. Pretty much what you have for grades now is going to be what you get for the 9 weeks. I will look at them, maybe I'll tweak them a little bit, but the third 9 weeks is definitely ending Friday. From now on, what we do here and what I teach you will be graded. We'll see what that looks like. Now don't panic on that because I'm not sure how many people are going to turn it in. With that said, also attendance is going to be started to be marked weekly, not daily. So you need to be logging on because I'll be keeping track, because you'll be getting a call from the office secretaries on that as well. All right? Okay. Now how we're going to approach lessons from now on is I'm going to teach you something new, and then I'm going to go over something that we've done in the past. Now for this week though, I'm going to start that chapter over on two-dimensional shapes. We did area of a parallelogram. This is today's date, so you know the date that you're supposed to be doing the assignment actually, which is Tuesday, tomorrow morning. We already did this, but I'm going to start the chapter over since we left off, March 13th. So the first thing I'm going to show you today is area of a parallelogram. I will have Ms. Galt post the formula sheet from the PSSAs so you can use it. However, the formula for this is quite simple. So let's talk about what a parallelogram is. It is a shape that looks like this. It looks like a kicked over rectangle. Okay? You do not concern yourselves with the diagonal lines. I've told you this already. That's for higher geometry. What you concern yourself with is, say, they have a number there, and then they usually give you a line like this, and they give you a right angle, and there is a number here. This is the height. This is the base. If they give you numbers for the diagonal lines, ignore them. What's the formula for area of a parallelogram? It is capital A, which equals area. And it's equals base times the height. It's as simple as that. And I told you before, you don't need to memorize these formulas. They'll be on the formula sheet. This is the simplest of them all though. So we have a height. So we got area equals base is 6. And we multiply it by the height, which is 3, which gives us an area of 18. And usually comes accompanied with some kind of measurement. We'll call it centimeters here. And when you do that, and you do two-dimensional shapes, you square them. You cube three-dimensional volume, and we'll get to that down the road. So this is what a parallelogram looks like. You're looking for a base, and you're looking for a height. All right? I don't know what else to say to that. It's kind of a review. You should be able to handle this. All right, so with that said, let me erase this, and we'll do one more. I'm not going to make you find the side of it. We're just going to go with area for now. So if I have a parallelogram like this, I don't draw the best parallelograms, but you get the point. There's usually a dotted line, and there's usually a 90-degree angle marker. Say this is 8, and say this is 10. So I'm looking at this. This is the base. This is the height. All right, and it's a simple formula. Capital A equals area equals the base and the height. All right, so I need the area of this. Area, there's the base, and there's the height. Now, if you mix these two up and you're not sure, I've told you a million times that multiplication is commutative. If you have these two numbers backwards, it's still going to work out no matter what, because you can flip multiplication around because it's commutative. And there's usually some kind of measurement here. We'll go with meters this time. And you got to put that there, and you have to square it because we're finding the area. This is a two-dimensional shape. Should be an easy review. I'm only going to make you find area of the parallelogram. Okay? So that's one part of the lesson, and Ms. Galt will post some problems on that for you to do tomorrow. I don't know, she might post them tonight if you're still up. I'm sure most of you are. Okay, so hopefully you'll see that, you'll write that down, or at least you'll watch the video again. That's the new part of the lesson. The review part, we're going to go back to the very beginning and we're going to multiply fractions. This is the review part of this. All right, so how do you do that? Well, you guys should know how to do it. There's a couple different ways of doing these. You'll have one with a whole number, and it'll look like that. There's your whole number. There's a fraction. This is one method of this. I'm going to give you another one where it's two fractions, and I'm going to give you another one where it's two mixed numbers. So this is the whole number versus a fraction. So let's see. I remember back in August or late August when we first learned this. The first thing you do is you put the whole number over a 1. You don't have to keep, change, flip anything here. We're not dividing. And then you bring this down. Now, I also taught you that you need to reduce your fractions in simplest form. I taught you a method called crisscross reduce, where I look at the relationships between the two numbers. Is there a relationship between 3 and 3? Yes, there is. 3 goes into 3 once, 3 goes into 3 once, which makes this nice and easy. 1 times 2 is 2. 1 times 1 is 1. 2 over 1. You do not leave fractions in improper form. 2 over 1 is 2. That's how you do this. All right, that is a whole number versus a fraction. All right, the second one will be a fraction versus a fraction. Let's do 3/8 times, I don't know, how about trying to find one that goes nice, and we'll say 3/9. Nah, let's go with 3/5. I want it to be where a fraction versus a fraction. Fraction versus a fraction. I was trying to look to see if I can make one to crisscross reduce. In this case, there's nothing to reduce. 3 and 5 are not compatible, and 3 and 8 are not compatible. So you leave it be, and you just multiply across. 3 times 3 is 9. 8 times 5 is 40, and you have your answer. All right, and that's it. You know this is in simplest form because there's nothing to reduce on the two matching, on the crisscross reduce on the fractions. Now, that is fraction versus fraction. Now, finally, what we have is a mixed number. We'll multiply it by, let's do it by another mixed number and see what we get. So these are mixed numbers. Now you have to turn these improper. There's no other way to do this. So this is the hardest part. You go 3 times 1 is 3, plus 2 is 5. You end up with 5/3. I converted this to an improper fraction. Bring down the multiplication sign. 8 times 2 is 16, plus 3 is 19, and that's over 8. There's nothing to reduce here. 5 and 8 are not compatible. 3 and 19, unfortunately, are not compatible. I need my calculator to make sure I don't mess it up. We're going to do 5 times 19, and we're going to get 95. This is a good one here. 3 times 8 is 24. Now I'm going to look at this. I can't leave this like this. It's improper. I need to turn it back to a mixed number. You need to see approximately how many times the number goes into 95. How many times is 24 going to 95? Well, it would be 2, 3, let's see. You got a trial and error. This 24 times 3 is 72. 24 times 4 is 96. Unfortunately, if this was 96, this would work out perfectly. So it goes in 3 times. Now that used up 72 of the 95. So if we take 95 and we minus off the 72, we get, we don't need to do that, forget that. We get 3 and 2, we get 23. So it ends up being 3 and 23 24ths. That's a weird one, I know. We almost made it where this would have been a whole number. Let me try an easier one of these, and then it might help you better. That one's kind of big. So let's see if we can find, I'm making these off the top of my head. So how about 1 1/3 times 1 and let's try 2/3. Let's see what happens here. All right, so 3 times 1 is 3, plus 1 is 4. Becomes 4 over 3. You always leave the denominator the same. 3 times 1 is 3, plus 2 is 5. Leave the denominator the same. Again, unfortunately, 4 and 3 can't be reduced, and 3 and 5 can't be reduced. Every one of these numbers up here, well, not all, most of them are prime. This one's not. So we just go across. 4 times 5 is 20. 3 times 3 is 9. This one's a little easier to understand. I can't leave this improper. 9 goes into 20 approximately, well, it does go into 20 at least 2 times. That used up 18 out of the 20. 20 minus 18 is 2. And that's how you do that, right there. All right? You shouldn't have a problem with these. They should be fairly easy. Now what's going to happen is Ms. Gall's going to post a page on parallelograms, finding the area, and she's going to post a page on multiplying fractions. All right? And you're going to do that for homework, which is Tuesday, 4/14. You're going to do that for homework Tuesday night, or Tuesday in the day, whatever. Then you're going to turn that in. And then the following day, which is Wednesday, I'm going to come back and review both of those papers. And we're going to give you an exit ticket. Couple problems on parallelograms, a couple problems on fractions, multiplying fractions. All right? It's not going to be a lot. I told her to keep the homework problems minimal, and I'll also keep the exit tickets small. So these are going to start going into the grade book. I don't think I'm going to do anything for the third 9 weeks with these. I'm going to put this in the fourth 9 weeks. All right? All right, that's it. So we're going to continue back the way we were. Let's review. Friday ends the 9 weeks, 4/17. I have a ton of grades from you from before we left. So whatever you earn there, you earn. We have a lot of grades. The fourth 9 weeks will start Monday, which is the 20th, April 20th. And that's when I'll start mounting your grades up from your exit tickets. You'll actually take tests when we get to the end of the chapter, and just like we normally did, before we even left. Okay. So exit tickets. Also, when there is a full week, I'm going to teach Monday, Tuesday, Wednesday, and Thursday. Friday will be a day for Alex. You will log on and you will do Alex topics on Fridays. But this week's a short week, so I'm just teaching lessons. So forget about Friday being for Alex topics. And that's it. I'll be available tomorrow to answer questions. We're supposed to be available from 9 to 2. Believe me, I get a ton of emails throughout the day from parents and students. If I don't get to you right away, I will get to you. We're not going to panic on this. This is going to be our first run at actual grading from online learning. I know your parents are concerned about it. Tell them to relax. You guys relax. We'll get through this together. I'm going to be as lenient as I could possibly be through the course of this. But I expect you to do the work. All right? There's no more, well, I'm going to turn this in a week or two late. Get on it, do it, because I'm going to do another lesson on Thursday. All right? Now remember, we do a lesson, homework, review the homework, exit ticket, just like we've been doing. And then we're going to continue through that with two-dimensional shapes three-dimensional shapes, and then back around into statistics to end the year. All right, there's not a lot of time left in the year, and like I said, we'll get through this together. All right, that's it. Hopefully you guys watch these videos, and please tell your friends to be logging on and doing these, because we're grading them now, and I'm keeping track on my sheets, just like I did when class was in session. So good luck with this, and I will talk to you guys actually tomorrow, which will be Tuesday evening, right? Tuesday evening, I'll talk to you, and we'll go over your homework pages. So if you're struggling with it, don't panic, okay? All right, guys. Hope you're safe and well, and we'll continue doing this for the rest of the year. See ya.